Let's solve this problem in a computer system where the best fit algorithm is used for allocating jobs to memory partitions. Okay, see, by jobs they actually mean processes. Okay, processes or jobs, both are same. The following situation was encountered, which means they have told that these are the partition sizes, and also they have given that we are using fixed partitioning. Okay, see, what do you mean by a fixed partitioning? The RAM will be initially partitioned before placing any processes. Okay, and that's what they are saying. They told that we have four partitions and each partition is of size 4 KB, 8 KB, 20 KB and 2 KB, because all are in KB, right? So let me draw the RAM. Let us assume this is our RAM. Okay, and we have four partitions, namely 4 KB, 8 KB, 20 KB and 2 KB. This is 4 KB, 8 KB, 20 KB and 2 KB. Now I'm naming all the processes, okay, P1, P2, P3, P4, and I'm naming all the processes, and they have given the size of the processor, which means it is having 2 KB, it is having 14 KB and all this. Also they have given the process execution time, which means this process P1 needs 4 time units, okay, and process P2 needs 10 time units to complete its execution. See, once we place the process inside the RAM, it will execute for some time, right? After that it will be removed from the RAM, and that's what they have given. It will execute for 4 time units, it will execute for 10 time units. Now the question they are asking is, when will the 20 KB job complete, which means when will the process P7 complete its execution, the time unit. Okay, they are asking at what time unit this process P7 will complete its execution. Fine. Now let me assume a Gantt chart. Okay, just like Gantt chart which we use for scheduling algorithms, let's assume something. Okay, let us assume we are having process at time unit 0. Okay, at time unit 0, let me put the time unit here, okay, on the top, because in the bottom I will be adding more processes. Okay, fine. Now process P1 is the first process which comes to the RAM, right? Now it needs 2 KB from the RAM. Now in case if we are using best fit algorithm, in which partition we will place the process P1? We will place it at the smallest possible hole, right? This is the smallest possible partition. And so I have placed process P1 over here. Okay, and this will continue its execution. P1 will continue its execution for 4 time units starting from 0. So P1 will continue its execution till 4. Okay, process P1 will continue its execution. Now process P2 needs 14 KB, which means process P2 can be placed only in this partition, right? It is not possible to place it in any other partition. So I'm going to place process P2 over here, and both P1 and P2 can execute at the same time, right? Which means at concurrently, which means process P1 will be executed for some time, process P2 will be executed for some time, which means they all can be placed inside the RAM, because this space is obviously free when process P1 is placed here, right? And so I'm executing process P2 starting from time unit 0. Okay, and P2 needs 10 time units to complete its execution. Okay, so it will take until 10 time units. Fine. So process P2 has started its execution time in the 0, and it will complete its execution time in 10. Fine. Now process P3 needs 3 KB, right? So where will process P3 be placed? The smallest hole is this, and so process P3 will be placed here. And process P3 will also concurrently execute starting from time unit 0, and it needs 2 time units to complete its execution, right? So it will execute till 2. Okay, it will execute till 2. Fine. Now process P4 size is 6 KB, and so P4 can be placed here. So I am placing process P4 over here, and process P4 needs 1 time unit to complete its execution. And so process P4 will also execute concurrently, and it will execute till time unit 1. Okay, P4 needs only 1 time unit for execution, and so process P4 will start from 0 and it will complete its execution at time unit 1. Fine. Now what about process P5? For a process P5 needs 6 KB. P5 cannot be placed in any other partition because all the partitions are completely occupied. Fine. Now when can we place process P5? We cannot place process P5 at time unit 0, because at time unit 0 the RAM is completely full. Now process P4 will come out at time unit 1, right? At time unit 1 process P4 will come out of the RAM because it has completed its execution. See, let me write all the processes: P1, P2, P3, P4, P5, P6 and P7. Okay, process P4 has completed its execution in time unit 1. Fine. At time unit 1, can we place process P5 over here? Can we place process P5 over here? P5 needs 6 KB and I can place it here. Process P5, I am placing it here. And it will complete it needs 4 time units, right? So starting at time unit 1, process P5 will continue for 6 time units. Process P5 will continue for 4 time units, right? Starting from 1 until 5. Right? Until 5. I am making this as 5. Until 5, process P5 will continue its execution. Fine. Now process P1 is completed and now we are at time unit 1. Okay, process P4 is completed. Now at time unit 2, process P3 will complete its execution, right? And so process P3 will be removed from the RAM. Okay, so P3 is also done. Now can we place process P6 at time unit 2? At time unit 2, process P3 left the RAM, right? At time unit 2, can we place process P6? P6 needs 10 KB space, right? So we cannot place process P6 over here, and so we cannot start with process P6 at time unit. We cannot start process P6 at time unit 2. Now can we start process P7 at time unit 2? Again, it is not possible because it needs 20 KB, whereas this partition has only 4 KB. Now can we start process P8? Yes, we can start because it needs only 2 KB space, right? And so process P8 will be placed at time unit 2. Okay, P8 will continue its execution at time unit 2 and it will execute till time unit 8. Okay, till 8 it will continue its execution. Where it will be placed? It will be placed here. P8 will be placed here. Fine. Now as of now, P5, P6 and P7 has not come into the RAM, right? The question is, we need to find out what is the time at which process P7 will complete its execution, right? See, one thing you can understand from here is, both process P6 and P7 can be placed only in this partition, right? We cannot place in any other partition because all the sizes are less. Here it is 10 KB and 20 KB, and so we can place it only in this 20 KB partition. Now when will this 20 KB partition will be freed? P2 will complete its execution at time unit 10, right? At time unit 10, process P2 will complete its execution, fine. Now at time unit 10, this will be freed, okay. Now once P2 is done, we will actually place process P6, right? Because P6 came before P7. And so process P6 will be placed at time unit 10 and P6 will be placed here, right? And P6 will continue its execution for exactly 1 time unit, which means from 10 till 11 it will continue its execution. Fine. Now at time unit 11, process P6 will be moved out of the RAM because it has completed its execution, and process P7 will be placed in this partition, right? And process P7 will continue its execution for exactly 8 time units. Starting from 11, it will continue for 8 time units. So 11 plus 8 is nothing but 19, right? Now at time unit 19, process P7 will complete its execution, right? So the answer for this question is 19. Okay, 19 is the answer. See, process P2 has started its execution at time unit 0 in this partition, and at time unit 10, P2 is replaced by P6. At time unit 11, P6 is replaced by P7, and at time unit 19, P7 has completed its execution and it is removed from the RAM. Okay, I know this question is a little bit difficult, but in case if you watch the video one or two more times, you will be able to understand it. Okay, so the answer for this question is 19 time units, which means in case if you are starting at time unit 0, at time unit 19, process P7 will complete its execution and so it will be removed from the RAM at time unit 19. Okay, fine.